This question is from the Practice of Statistics 5th edition. The authors are Stearns, Tabor, Yates, and more. So let's continue to analyze this question. To see if birth date is related to success, a random sample of 80 NHL players from a recent season was selected and their birthdays were recorded. The one-way table below summarizes the data on birthdays for these 80 players. Number of players who were born between January and March were 32. April, June is 20. July, September 16, and October 2. December is 12. Do these data provide convincing evidence that the birthdays of NHL players are not uniformly distributed throughout the year? Let's see if there is any relation between birth date and the success. The first thing we need to do is state our hypothesis testing. So H0 is the birthdays of NHL players are evenly distributed across the 4 quarters of the year. And the alternative means the birthdays are not evenly distributed across the 4 quarters of the year. So we will analyze to see which one is correct. Since significance level is not given, we can use alpha as 0.05. The biggest question is what tests are we going to use? Let's see if we can use chi-square test for goodness of fit, since we have proportions. So we are going to compare proportions. First of all, we need to check if our data came from a random sample of NHL players. The next condition was 10% condition. So we're sampling without replacement. There must be at least 10 times AD, which is 800 NHL players. In the season when the data are collected, there were 879 NHL players. So the following condition is large counts. So what does this mean? If birthdays are evenly distributed across the 4 quarters of the year, then the expected counts will be 80 times 1/4, which is 20. These counts are at least 5. And all these conditions met. Let's remember the chi-square formula, which was observed minus expected, square over expected. So the observed we have 32, 20, right? 16, 12. But since we have 4 periods, our expected birth counts will be 20 in each. So between January to March, April to June, July to September, and October to December. These are the birthdays we will expect. And 32 minus 20 square over 20, because this is sum notation. So if we apply the formula, we are going to have 20 minus 20 over 20 square plus 16 minus 20 over 20. There is square here, and 11.2. Our chi-square in this case will be 11.2. What does this mean? So since our alpha is 0.05, we need to find the p-value for chi-square 11.2, so we are going to compare. We can use technology or table, so degrees of freedom is going to be 4 minus 1, which is 3. And if we use technology, our p-value will become 0.011. So now we need to compare these two numbers to make the conclusion. Because p-value is less than alpha, which is 0.05, we reject H0. What does that mean? we have convincing evidence that the birthdays of NHL players are not evenly distributed. So if you go back to the question we had here, null hypothesis, the second one was the birthdays of NHL are not evenly distributed. So if you look at the data, actually we can have some type of ideas. However, if we increase our sample size, things can change. That's why we are not 100% sure. We are 95% sure because our alpha is 0.05. As a result, we can say that birthday is related to success.